Today we are talking about scatter plots. The SAT absolutely loves to give you these. Reminder, you're taking the SAT in exactly 1 week and 1 day. I am keeping track. You're welcome. Couple definitions. A scatter plot is a type of data display that shows the relationship between two variables. Looking at these three examples here, it gets its name from having a scattered array of points, if you will. And those can show up in different formations. There are different types of correlations between the points. It's a relationship between two variables. We have positive, negative, and no correlation. These very much should remind you of slope. That's exactly what I'm going to compare them to. First off, positive correlation is like positive slope. How it goes up to the right. When you have a positive correlation, that means as x increases, as x moves to the right, that's where it increases. Y increases. Negative correlation, similar idea, but the opposite. It's like negative slope. How it goes down to the right. As x increases, meaning as we move to the right side of the graph, you see the points go down, so y is decreasing. There are going to be times where there is no discernible pattern, so there is no correlation. That just means there is no relationship between x and y. There's one more thing to consider when it comes to correlation. There's another aspect of it. If it's strong or weak, this has everything to do with how close or far apart the points are to each other. The closer together, the better the relationship, and the further apart, the weaker the relationship. So a strong correlation is when most points are close to the line of best fit. We'll talk about line of best fit in a moment. Weak correlation is the exact opposite. Points are not close to the line of best fit. Let's look at an example below. Since scatter plots are made using data, the majority of the time they will have some kind of context behind them. Usually it's scientific in nature. This is a scatter plot representing the concentration for carbon dioxide in the air. And you'll see that these points have a line among them. This is the line of best fit. Let's take a look at some aspects of the graph first. Along the x-axis, we have years ranging from 1970 all the way up to 2010. The y-axis, they give us amounts of concentration, starting from, it looks like 300 going to 380. I assume this top notch that's unlabeled is 400. Lastly, it's very small, but this text down here, the top line of it is an equation. We are going to use that equation. I'm going to rewrite it, but much larger. Y equals 1.6178 x minus 2864.6. Underneath the equation, that r squared number, that is referred to as the correlation coefficient. We're not going to cover that in this class. Couple questions here. First, we're going to identify what type of correlation this graph has. First, we identify it as strong or weak. As you can see, these points are very close together, forming almost a perfect line. That is a very strong correlation. The other thing to note is that as we move to the right, this graph goes up. This is a positive correlation. Number 2 really gets at the type of problems that you'll expect to see on the SAT. The SAT is really concerned about your ability to read and interpret the data in the scatter plot. Number 2, what value does the model predict for the concentration of carbon dioxide in 2000? So this means 2000 is our x value. There are 2 ways to answer this question. We're going to do both of those for this graph, but most problems you're only going to have one or the other available for you to use. First, let's just look at the graph to answer this. We'll make a graph prediction. Looking at our graph here. First, we need to find this x value, 2000. It is right here. We'll identify a point to help us guesstimate what the number is. Connects to that point there. It lands somewhere in the middle of 360 and 380. That's quite a range, quite a guess you'd have to make. Since it lands almost in the middle of the two, a very safe answer would be around 370. So we'll just put down 370 as a solid answer. Now on the SAT, which is multiple choice, you would have a list of options to choose from, and one of them would be very close to this, and then the others would be enough off of it that you would know they're wrong. There's an even more accurate way to get this prediction, and that's using the equation that they give us. So we'll make an equation prediction. If they give you an equation, use it. Equations are always going to be more accurate than just eyeballing it on the graph. Again, our equation is y equals 1.6178x minus 2864.6. And our x value is 2000. We'll plug that in and get our answer. That is not what I got. Look at it again. Probably a typo. It's really close to that. No? Look at it. Let me see it. Oh, you wrote 7 2. It should be 7 8. Let me make sure the rest. Oh, I remember the answer. Yeah, that's right. If you type this in correctly, you should get a nice 371. No rounding necessary here. So there is the graph versus the equation prediction. Very close, as you can see. So either one would have been a great option. But again, it all depends on what the problem actually gives you to use. Questions on the front side before we go to the back? All right, back side. Line of best fit, I've already discussed it a little bit. I'm going to give more context to what that is. A line of best fit is a line drawn on the scatter plot that represents the data a little more specifically, it should be in the middle of most points. To explain this a little more, I'm going to go back to the front page real quick to look at that line of best fit. This kind of implies the name that we give it, but these points here don't form a perfectly straight line. If they did, we could just find that equation. So the line of best fit gives like a model to help us show what the data means, the pattern in the data. But since they are scattered points, and the more scattered you get, the worse the model is going to be. But we can still find one. So we call it best fit because it's the best equation for those data points for that scenario, but you're never going to find a perfect line unless they form a straight line. So you'll notice that several of these points along this line here are above the line, below the line, or slightly on the line to some capacity. We have collectively decided that it is not necessary to teach this, so above number 4, don't mark out number 4, but you are welcome to cross this part off of the notes. If you run into this on the SAT, it will more than likely be on the multiple choice section, so you can use your knowledge of lines y equals mx plus b form to match the equation to the graph. And we'll focus on the more important part of the notes, which is being able to read, again, the scatter plot telling relationships. Car driver age. Data was recorded on the age of drivers and the number of car accidents per 100 drivers in the year 2009. The data is shown in the scatter plot below. Looking at the scatter plot, x-axis, we go from age 16 all the way up to 25. Just notice real quick the 16-year-olds have the most accidents, just worth pointing out. And then we have the number of accidents ranging from 9 to 24. What is the best description of the relationship between age and the number of car accidents? A, older drivers tend to have fewer accidents. B, the older drivers tend to have more accidents. Or C, there was no clear relationship between age and the number of accidents. When you get a problem like this, you always want to address C first because that's stating there's no relationship at all. So it's either C is correct or it's completely off, like not even possible. So Looking at C, we can clearly see a descent pattern happening here. It's a downward pattern, so in that case, C is absolutely not correct. So we have to interpret what it means when the data is going down. As we move to the right, as the age increases, the points go down, the number of accidents go down. A is the correct choice. Older drivers tend to have fewer accidents, less accidents. A is correct.